Hello, everyone. This little video is going to be a demonstration of how you can use a particular kind of tool here called at pythontutor.com, which is a really great tool to help visualize variables in Python. So this is actually going to tell you a little bit more about how Python works and how variables are actually stored, which should illuminate a little bit of, like, when we create variables, what's actually going on with them. So this is a pretty great tool. I'm going to click to start writing and visualizing code now. And it's going to come up with this use interface here where we can sort of type in some Python code. And you can see that we can do this drop down here. We can pick different languages. I'm going to stick with Python 3.6, which is kind of an old version of Python, but it should work for what we're doing here. There's a few other options here that I want to show. In particular, this middle option in this drop down right here. I have currently got this set to render all objects on the heap. The default is inline primitives don't nest objects. I'm going to start off with this set to render all objects on the heap. Eventually, I will turn it off so that numbers and strings do not render on the heap. Now, so first of all, what the heck is the heap? Okay. So as we run this, we will see the different places in memory where Python stores things. So let's start off with something really, really simple. Let's start off with just like a variable called a, and let's set it to 1. Okay. And I'm going to hit this visualize execution. This is kind of like a debugger, like Thonny or something, where it's just going to run the code one line at a time and we can step through it. Now, there's only one line of code here. What will happen is over here to the right, it will create a diagram of what memory looks like as our program runs. So I'm going to hit visualize execution here. And it's going to, this little red arrow is the next line to execute when I hit next. There's only one step here since this is a one-line program. So we're going to hit this, and here's what happens. You got this section over here in the side where it's showing you what's in memory. There are two sort of places in memory where things are stored in Python. One of them is in these what they're calling frames. Okay, this is also sometimes known as the call stack because it's going to be a stack of variables that will, and it's weird because when we draw stacks in computers, we often draw them upside down from a stack of plates going up this way, and it's actually upside down. So the bottom of the stack is up at the top, and then the top of the stack. So right now there's only one thing on the stack, the a, because we did a equals 1. And what happened was over here in objects, this is the heap, and the heap is just a bunch of memory out there in the computer that's just wherever you want to put it. But the stack is like a stack of memory where you're just stacking stuff up. So it puts a letter called a on the stack, or a symbol called a on the stack, because that's what we're naming our variable. And you can see this arrow here is pointing at over here in memory. There's this object, and that is the integer object representing a 1. So Python has created an object in memory. And our variable a, which is on our stack in our global frame, it's global because it's a global variable, is pointing at that. What that really means is that a is just storing the memory address for where this object is. You don't really need to know what that memory address is or how that works, but that's what's actually going on. So, so you can think of variables as pointing at things, and that's really the thing that I want you to hone in on here, is that variables point at things. Okay, so a points at 1. Okay, so that's fine. Let's go back to edit this code and let's add something else. So I'm going to say b is equal to a. Okay, so this is making another variable and it's pointing at a. And you might sort of think that the diagram that we're going to get is that a points at 1 and b points at a. But that's actually not what's going to happen. So watch what happens when this runs. Okay, so we're going to run the first line. The first line of code creates the same thing we saw a minute ago, an a, which points at 1. B is going to point at a now. However, Python doesn't put a b here and have an arrow loop back up to a. That's not what happens. Okay, what's actually going to happen is it's going to create another variable called b that also points at 1. There is one object for this 1. It's sitting here in memory. And both of these variables point at it. So there's an analogy we sometimes use in programming when we're teaching, and it is that variables are like buckets and you put things in them. That analogy sort of breaks down in this case because this would be like if you could put the same thing in two different buckets, right? So I think a better way to think about it is to think about it as the variables exist here and they point at the real thing, whatever that real thing is, if it's a number or a string or whatever. In fact, let's add some different kinds of things in here and see what happens. So we'll go ahead and leave this in here, and then we'll create a like a Boolean called C, and D will be a string like hello world. And let's visualize execution on that. So there's our A, there's our B pointing at that. We do true, there becomes a Boolean object with the value true that C points at. And then there's a string object, you can see the type here, that contains the string hello world. Cool. But what about more complicated things than just simple variable data like this? What about lists? Okay, that's a good question. What do lists look like in memory? Let's go back to edit this code and let's make a list and let's put some things in the list. So let me comment this out first. And let's make a list here called fruits. And we'll put apple and banana and orange in it. And let's run this and see what does a list look like. I'm just going to skip all this because those are commented out. What does this look like in memory? This is what it looks like. So the variable fruits points at a list object in memory. List objects are special because they have indexes, right? We know that, right? Index 0, index 1, index 2, right? Those indexes have things in them that point at objects, string objects. So there's 3 string objects here, apple, banana, and orange. Index 0 points at this one. Index 1 points at this one. Index 2 points at this one. So you can see how what's happening in memory is everything are these things that point at other things, right? So the indexes are also like the variables in that they just point at things that exist in memory. Okay, let's go back and edit the code again. What happens if I make a new variable, and I'll call it a fruit, and I go say fruits at index 1. Now that would take banana and assign it to a fruit. So if we were to print a fruit, right, that would print banana because that's how you do that. You access the fruits at index 1. This is index 0. This is index 1. So it's going to be a banana. But what happens in memory? Do we make a copy of banana and have 2 banana strings? No, we don't. Watch what happens. So firstly, we create our fruits. It has a apple and a banana and an orange. Then we go, give me the fruit at index 1 and assign it to a variable called a fruit. This is what happens. The variable a fruit gets created. It's a global variable. It now points at the same exact string that index 1 points at. Right? So Python isn't going to make another banana string and put it in memory somewhere. It's going to use the one that's already there, right? They're both going to point at the same thing. If I print out a fruit or if I print out fruits at index 1, the same banana string is in both places, right? Cool. Maybe cool, maybe confusing, but you can see how it's being efficient. It's not making extra banana strings when it doesn't have to, right? Okay. So that's cool, but what happens when I do a loop? For fruit in fruits. This is the way you loop through the list, right? And then maybe I'll just print out the fruit each time. Really simple sort of loop where we print out the things. Not doing anything other than just looping and printing. Let's visualize this. Okay, so creates our list the same way. We're going to start looping through for fruit and fruits. So I hit next. It creates a variable called fruit that points at the first thing in the list. because that's what loops do. That's what the for loop does. It creates a variable called fruit, and it points it at the first thing in the list, which is apple. So when I print fruit, it's going to print whatever fruit is pointing at, which is apple. So there you go. It prints apple. Then the loop is going to run again, and the pointer changes. The fruit now points at the second thing in the list. This is all the loop is actually doing. It's just slowly pointing at everything in the list and changing fruit to go to that thing. So it's going to print banana, and then it's going to finally loop here to orange, and then it is going to print orange. And then the loop's going to back to the top, and it's actually done. Now, you'll notice that fruit, at the end of the program, fruit is still pointing at the last thing. That's true. That happens in Python. You could print fruit outside the loop, and it would be the last thing because it's still pointing at orange. Okay, let's do something even more complicated. Let's talk about functions. Okay, so let's just leave all this out. Let's make a number called a, which is 1, a number called b, which is 2, and let's make a function called add that takes in 2 numbers. Okay, and returns num1 plus num2. Then down here, let's call add and assign a and pass it a and b. Okay, and assign the result, whatever gets returned from here, to result. And then for fun, let's print result. Although we don't need to, since we have a visualization tool where we can look and see what the computer's doing. We don't really need to print anything, but let's watch this. Okay, so visualize execution. So a gets created, points to a 1 object. B gets created, points to a 2 object. The function gets created. Oh, wow. This is cool. The function is a variable. Yeah, you didn't think about that, but the name of the function is a variable. It points at a function object. Yes, functions are objects in Python. So this function object is over here in memory. That's so we can use it later, right? The whole point of doing def is to define it. So you can see when we define it, what we actually do is we put the function in memory so we can use it later. Now here's the later. We're going to call it here. So we're going to call it and pass it a and b. And when we do that, it's going to run the body of this function. And there's a few things that are going to happen all at once here when I hit next. Okay, ready? Whoa, what happened? We got a new box here in the frame side. The call stack, so far we've only seen the global frame, right? Global variables. What happened now is that Python created a new thing, a new frame. They're called stack frames. It created a new one for this function call. Okay, this function call gets a stack frame, and the parameters, num1 and num2, get declared as variables automatically. And they point at whatever was passed in. But you notice we passed a and b in, but it didn't, num1 does not point at a. What does it do? Just like when we assigned b to a or earlier, like num1 is pointing at the same 1 object that a is pointing at. You'll also notice these are gray. That's just trying to emphasize that right now, this is the active frame. So these dark blues are the ones we're dealing with right now because we're up here on line 4. All right. So num1 and num2 are here. So now it is going to add num1 and num2 together. So when that happens, right, the add function is going to add the 1 and 2 together, and a 3 will get created. Okay, right? Because it's going to add 1 and 2, and there's going to be a 3 object. Bam, there's a 3 object because it did the math and stored it in memory. And you'll see that there's a special thing on the stack called return value. So the return value is now pointing at 3 because we've returned. Okay. Now, what I want you to watch is these variables, num1 and num2, and this return value thing, they go away once this function returns. And there's a thing in Python called the garbage collector that will come and actually free up the memory once that's gone. This entire stack frame will get deallocated out of memory and go away. So watch this happen. It's going to go away. Boom, gone. But the 3 is still there. Why is the 3 still there? Because we assigned it to a variable. So the 3 is still in memory because result is pointing at it. In fact, what determines if something sticks around or not is whether or not anything is still pointing at it. If I did not assign result to anything, the 3 would have went away. In fact, I could prove that. Let's edit the code and take out the assignment. Let's just call the function and not print it and watch what happens. Okay, create our 2 numbers, create our function, call our function. Num1 is this, num2 is that. Still does the math, still creates a 3 object. The return value is set to 3, but watch what happens when the function returns. The 3 object even goes away because nothing's pointing at it anymore. There's no variable to hold it, if you want to think about it that way. So it disappears, not available. I mean, obviously it's not available. I can't print it, right? I don't have anything for it. Now, if you just wrap a print around this, okay, and you run this, it will get printed out. Here's the 2 numbers, creates the return value of 3, and then it prints it. But after it's printed it, the 3's gone. So like if there was a line 8 here, it would not be there, right? Because we didn't assign it to a variable. We did pass it to print. And actually, this thing does not show the stack frames for built-in functions, but the print function has a stack frame that gets created, and then it prints it, and then it returns from it, right? Because print's a function, just like every other thing else. But this tool does not step through built-in functions, so you can't see it, right? All right. Let's do something more complicated. Let's take a list and pass it to a function. Okay. So let's make, there's a function that we did called longest word. We pass it a list of words, okay? Then we do something like this. We say the longest is equal to the word at index 0. And we for word in words. And we if the length of longest, or actually if the length of word is greater than the length of longest, okay, we're going to set longest equal to the word. And at the bottom, we're going to return longest. This was the problem that pass it in a list of words. It will determine which word is the longest. If the word we're looking at is longer than the longest, we set the longest to that word. Then at the bottom, we return longest. So let's watch what this looks like in memory. So let's go ahead and make a list. I'll use my fruits again. Apple, banana, orange, and I'll do pineapple. Since it's a really long word, that'll be our longest word. And then I'll call this longest word, and I'll pass it fruits, which is our list. And let's visualize this. Here we go. So the first thing that happens is line 3, it's going to create a function, create a global thing called longest word, and create a function object. Now we're going to create a fruits. There's our fruits with all 4 of our strings as objects. And now we're going to call longest word and pass it fruits. We get a new stack frame. It has a words variable. The words variable points at the same list that fruits does because we passed fruits to here, so fruits becomes words, right? So words and fruits, right? Because this is the argument and this is the parameter, they both point at the exact same list, right? That's important to note. They both point to the same list. Python's not going to copy the list and make a copy of it, just like it's not going to copy the string. It tries to be efficient here. It doesn't make a copy of the list. It just uses the same one, right? Okay, so now we're going to say longest equals word 0. So what do you think is going to happen here? Well, it's going to create a variable called longest. We know that. What is that going to point at? Is it going to point at index 0? No. It's going to point at apple. Because what happens is you say longest equal words at index 0. It goes, what's at index 0? Oh, it's this thing up here. So therefore, longest is pointing at apple. Interesting, huh? So longest is now pointing at apple. So now I'm going to go to my loop. This creates a variable called word. It also points at apple. Because when loops start looping, they start at the beginning and they loop at index 0, 1, 2, 3 until it's done, right? So it's going to start here at index 0. So that means word will point at apple. So then it's going to do if length of word is greater than length of longest. Well, in this case, that's the same word. Longest and word are both pointing at the same word. So the length is going to be 5, right? In both accounts. So since that's true, false, it's going to just jump back to the top of the list. It's going to go for word and words. Okay, so now word is going to move to banana. So banana is 1 letter longer than apple, right? So now you'll see longest is pointing at apple, but word is pointing at banana because the loop went on to the next iteration. So it's going to go if length of word is greater than length of longest. Well, this is true. The length of the word is going to be 6. Length of the longest is going to be 5. So it will go and it will go into here and it's going to say longest equal to word. Watch what the variable longest does. It just moves to point at banana. Cool. So now we're back at the top of the loop. We're going to switch our loop variable. Word is going to go to orange. Okay. And then it's going to check if orange is longer than that. It's not. Orange is 6. This is 6. So this is going to be false. So it'll just go to the next thing. So it goes back to the next thing. Word will now point at pineapple. Okay, we're fixing to change something again because pineapple is longer than banana, which is what we're currently pointing at. Longest is currently banana. Okay, so we're going to go to here. We're going to say longest equal word. Bam. Longest is going to equal pineapple. Okay. Then what are you going to do? You're going to return longest, so the return value of this function also points at pineapple. And then, of course, it will return. Now, when it returns, all that goes away, but fruits is still there because the variable fruits still exists. Okay. But I didn't assign the word that we're returning. I didn't assign it anywhere. I didn't pass it to print. I didn't do anything with it, so it disappeared. I'm going to edit this and actually save it in a variable called result and then print result. And I'm going to run this again. Let's step through it kind of quick and watch it like it's an animation. Ready? Watch the arrows as we loop. Now we're down to the return value. So we loop through the entire thing. We figured out that pineapple is the longest word. We're going to go up here and you see result points at pineapple because that's what we returned, right? And so it gets assigned to result. And now we're going to print it. But the other thing you notice is that these variables, right, they all go away. I went backwards, by the way, there. You can go backwards with this tool, which is kind of cool. So you can go, once we return, that stack frame goes away, all of those variables go away, and now it's like this. Now, as you can imagine, if code gets really complicated, all of these arrows can get really wacky and hard to understand, right? Right? This is already a lot of arrows. If you had like a list with lists inside of it, it would get even more complicated. So that's why this tool does have an option here that we looked at a minute ago, which is inline primitives don't nest objects. What this does is it makes it so that it doesn't draw arrows for strings or integers or booleans or basic types. So let's show you what that looks like. So that looks like this. The function still points over here, right? Fruits is like this. So see, it doesn't show all the arrows pointing away at the individual string things, right? And then when you get here, it actually, words does point at the same list, right? Longest, though, it just shows it here. So this is kind of a lie because really longest points at the same string. There's not two apple strings. So this version of the tool is kind of a lie, but it's here because when you start doing really complicated things, all the arrows can get in your way of seeing what's happening, right? So just be aware that if you want to see the truth, you need to set it to that other setting, that this is kind of fudging it a little bit to make the picture simpler, right? But you can still step through this and see what happens. The longest is apple, right? The word is apple. It's comparing apple to apple, right? And then, of course, the word is banana, so it makes longest banana. And then the word is orange, and it doesn't change longest. Then the word is pineapple, makes longest pineapple. Then it's going to return, so the return value is pineapple. And then it returns, and the result is now pineapple. So it can still be useful if you're stepping through stuff, right? But if you want to visualize really what's happening, the other option, which is render all objects on the heap, is going to be more accurate. Let's look at something else. Let's look at a dictionary. Okay, so let's make a dictionary called user, and we'll give a name, Bart, and then we'll do a, let's see, occupation. And my occupation is instructor. So there's a dictionary. Let's see what that looks like. Now remember, I've got it on render all objects to heap, so we're going to see all the strings as their own objects. So we visualize instruction, execution, we create it, bam. Okay, now this is already starting to get wacky. The user points at a dictionary object. The keys in the dictionary object are strings and point at string objects. The values are also strings, so they point at string objects. And I don't know if you can see, but like it's hard to see, because there's a lot of arrows here. But this arrow here points at that. If you hover over the arrows, it highlights them. This arrow points at that. So the dictionary is made up of key value pairs. You notice there's no indexes. It's just key value, key value, key value, right? Let's edit the code again. Let's go get the name out and store it in a variable called name. Name equal user square bracket name, like that. Let's visualize that. Create our complicated dictionary. Then we do name equals username. And name is now pointing at the string Bart, because that's the value, right, of the key here, right? Now, if you're dealing with dictionaries, that's hard to look at. So this is one of those places where the inline primitives view will simplify things a little bit, right? So it'll actually show you the dictionary like this, which is much easier to read than having all the arrows pointing out at the individual string objects. And then, of course, this will just show that. But even this can be useful when we have things like a list of dictionaries. Okay, so let's do that. So let's make a users list. Okay. And I'm going to name this variable Bart instead of user. And I'm going to put the users list below it here. Okay. And I'm going to put Bart in the list. And I'll make another one for J. Name. J. Occupation. Instructor. Okay, so then I'll put J also in the list. So now these are both dictionaries. I've put them into a list, right? Let's get rid of that and let's see what this looks like. This is a list of dictionaries. And I'm not going to turn on the heap. We can turn that on and look at it if you want to, but it's going to be very complicated. Here we go. Okay, there's a dictionary. There's a dictionary. And there's the list. So look, users is a list, points at a list in memory. The list object has an index 0. The index 0 points at this dictionary here. So when you're dealing with like stuff like dictionaries list, this is already more complicated. This is plenty complicated, right, for us to look at. But it also lets us visualize what's happening with these. But we don't need to visualize all the strings necessarily. Let me show you what that looks like, just so you can see why, like, you maybe don't want this render all objects in the heap when you're using this tool for every situation. Okay, here's what that looks like. There's the first dictionary. Here's the second dictionary. There's the list. Okay, already we're seeing, wow, there's a lot going on here. lots of arrows. You'd have to spend time to like trace them down. Here's the users pointing at this list. This is pointing at this dictionary. Then the dictionary has keys that point at these strings, right? Also, this is fun. Python is sharing the key names between these two dictionaries. Python has this thing where if it already has a string named that, it just keeps it. It doesn't make another one. It's an optimization. So both the keys name both point to the same name string. That kind of wild? Never would have guessed that, right? So it's just being efficient by not duplicating the name string because we used it again. So yeah, so when you get complicated in a complicated problem, I would recommend maybe not doing this. If you have simple code and you would like to see all objects on the heap so you can understand how it works better, do that. If you're just trying to debug what you're doing, this is probably better because it's going to show you in a much simpler way what's happening. But that's it. Every time you call a function, you get a stack frame here. In the frames over here, it only contains variables, and those variables point at objects over here. And everything's an object in Python. Strings are objects, dictionaries are objects, lists are objects. And variables are just things that point at those objects. They are not buckets. They are things that point at other things. I'll relate this back to a couple of functions in Python. Okay. Let me delete this complicated dictionary thing and let's go back to something simple. So if I do A equal 1 and then I do B equal A, I can print out condition A is B. The is operator will tell me if something is the same object or not. So if I run this and we just watch what it prints true because of the same object. Why are they the same object? Because if you go switch this to heap version, the heap version, you'll see that A and B both point to here. So you're actually asking, does A point at the same thing as B? That's what the is operator does. And to get even more complicated or even cooler about Python, if you print the ID of A, this is a function you can use, and the ID of B, and let's watch what it prints. It's printing the same number. This is sort of it's not really a memory address, but it's an identifier for this object. It's a unique identifier for that object. So you can see that since the two identifiers match, these are the same object. So Python has some cool stuff to kind of look at memory and to like find out what's going on with your code. And the is function and the ID function are part of how you can do that if you care. We usually in normal code, we don't care about this. We don't really care that these things are pointing into it. Let me show you some situations in which this matters. All right, here we go. Let's make a fruits list like we had before. Apple, orange, banana. Now, let's make a function. This function is going to be called add_to. And what add_to does is it takes two lists in, list 1 and list 2. And what it does is it adds all the items in list 2 to list 1 and returns list 1. So we can do that by looping through list 2. For item in list 2, list 1.append item. And then return list 1. Okay. So fruits is here. Let's make another list called more fruits. And we'll put banana, excuse me, pineapple, and say mango. Okay. So I'm going to say, okay, all right. So I'm going to call this function add_to, and I'm going to pass it fruits and more fruits. Okay. And then I'm going to print out the result. The result should be another list, right? And this list should have all the 4 things in it because we're going to loop through this one. right? And then we're going to take pineapple and append it to the first one up here. And then we're going to append the next mango to it. Then we're going to return that. Okay, we have it set to render all objects on the heap. We're going to hit visualize execution. And I'm going to prove to you why this is important for you to know this. So, in the global frame, we have a fruits variable, points as a list that has apple, orange, and banana in it. Then we have another list called more fruits that only has two things in it that points at the strings pineapple and mango. And we have a function. Now we're going to call this function. When we call it, we get a stack frame. In the stack frame, list 1 is pointing at this one, which is the fruits list, right? List 2 is pointing at this one, which is the more fruits list. You can see how fruits and list 1 point the same thing, and more fruits and list 2 point the same thing, because that's what we did. We passed those two in. By the way, this is called passing by reference, because we passed a reference here. And these things are all references. They all refer to the thing in memory, or they point at it. Okay, so let's watch what happens when the loop runs. So the loop's going to go for item in, make an item. Item's going to point at pineapple first because that's the first thing. It's going to append pineapple to the first list. So list 1 is going to get pineapple appended to it. However, we did not create a new pineapple string. Okay? 3, which is index 3 now, points at pineapple. So does item. So does index 0 of the list. Okay. Now item is mango. We're going to append mango to the list. Same thing happens. Item 4 points at mango. Item still points at mango. Item index 0 of this list points at mango. We have 3 things pointing at mango now. Now we're done with the list, the loop. We're going to return something. The return value points at this list. And then now we're here, and result points at this list. Fruits and result point at the same list. This might not be what you would have predicted. So for instance, if you print result and you turn around and print fruits, prints the same thing. Unknowingly, we passed fruits to this function, and this function modified fruits. That's called a side effect, by the way. We had the side effect of calling this function is that we actually modified list 1. We didn't get a new list back. There are ways to make a new list in Python. We could have done that, and then we would have had a new list, and fruits would not have been messed with. But you need to be aware that when you pass a list to a function, you can modify that list and return it, and you've modified it. In fact, you could modify list 1 and return list 2. List 1 would still get modified. All right? We were modifying it as we were going. So that's why it's important to understand this stuff, because like these variables point at objects, and these objects are not copies. There are no copies being made. Okay. If you wanted to make a copy, you would need to basically make sure you do that. So how would we make a copy? Here's how we would change this code to make a copy instead of using the original list. So we need to make a copy. I think there is a Python function that will actually do this for us. Let me see if I can remember what it is. Go to the Python documentation, docs, and let's look at the library reference. Let's look at lists. And let's click on list. Here's list. List has sort. What are their common immutable sequence operations? Here's all the common ones. I believe there's I thought there was like a copy or a clone. Copy. Creates a shallow copy of S. All right? So you can call copy and it will make a shallow copy. So that's what I was thinking of. So let's say new list equals list1.copy. Then let's loop through list 2 and let's append to new list and return new list. In doing this, new list. In doing this, we are making sure we make a copy of the new list first, loop through list 2, and append each item onto new list and return new list. We will not mess with fruits. We will leave fruits alone. Let's just, to prove this to ourselves, let's print fruits and also print result. And let's visualize this. Here we go. Ready? Fruits is this. More fruits is this. We're going to define a function. Now we're going to call this function. We're going to pass it fruits and more fruits. So list 1 is still pointing at this fruits list. However, we're about to do the copy. When we do the copy, we get a new list. Now, you notice this new list still points at the same 3 strings. We didn't make copies of the strings. The strings are still the same strings. But we do have a new list. Okay? So that means as we loop through list 2, we are now appending, see the 3 here pointing at pineapple, we are now appending to the new list. We're not messing with fruits. It's still the same. And then we append mango to this one. And now we're going to return it. So our return value is this new list. All that goes away. And now fruits is this list. More fruits is this list. And result is the new list with 4 things in it. So this is a way to avoid like modifying the original list. Make a new one. Another thing you can do to do that, and we'll learn about this later, is list comprehensions also make new lists. So they can be a really good choice for this sort of thing instead of a regular for loop. So anyway, let's print them just so you can see. So when I print it, fruits is still this, but result is now this new list that has both of them on it. So I've kept the original list, and I also have a new list. So yeah, so I hope you've seen now why it's kind of important to understand that variables point at things and trying to understand that. I would recommend if you get lost in a piece of code or you're having a weird problem with it, Thonny is a really good choice for stepping through and seeing what's happening. This tool can be another really good choice for seeing what is happening with your variables in memory. Anyway, I hope that was really helpful, and have a good rest of your day.